Assalamualaikum warahmatullahi taala wabarakatuh, and good morning to our beloved lecturer and friends. Today our group will be presenting about chapter 12, which is long-term financing. Now let's take a look at bond valuation. So what is bond? Bonds are long-term debt securities that are issued by corporations and government entities. Purchaser of bonds receive periodic interest payment called coupon payments until maturity, at which time they receive the face value of the bond and the last coupon payment. Most bonds pay interest annually. The bond indenture or loan contract specifies the future of the bond issue. Terms to describe bond. The first one which is the amount of money that is paid to the bondholders at maturity. The next one is coupon rate, which is generally fixed, determines the periodic coupon or interest payments, expressed as a percentage of the bond's face value. The next one is coupon payments, which is represent the periodic interest payment from the bond issuer to the bondholder. Annual coupon payment is calculated by multiplying the coupon rate by the bond's face value. The next one is maturity date, which is represent the date on which the bond matures. Example, the date on which the face value is repaid. Last coupon payment is also paid on the maturity date. The next one is original maturity, which is the time remaining until the maturity date when the bond was issued. Next one is remaining maturity, which is the time currently remaining until the maturity date. Next one is call date, which for bonds which are callable. Next one is call price, which is the amount of money the issuer has to pay to call a callable bond. The next one is required return, which is the rate of return that investors currently required on bond. The next one is yield to maturity, which is the rate of return that an investor would earn if he bought the bond at its current market price and held it until maturity. It represents the discount rate, which equates the discounted value of a bond's future cash flows to its current market price. The next one is yield to call. The rate of return that an investor would earn if he bought a callable bond at its current market price and held it until the call date given that the bond was called on the call date. So the box above illustrates the cash flow for a semi-annual coupon bond with a face value of $1,000, a 10% coupon rate, and a 15 years remaining until maturity. Note that the annual coupon is $100, which is calculated by multiplying of the 10% coupon rate times the $1,000 face value. Thus, the periodic coupon payment is equal to $50 every 6 months.
Next, we go to the bond price. The price or value of a bond is determined by discounting the expected cash flow of the bond to date using an appropriate discount rate. This relationship is expressed by the following formula for semi-annual coupon bonds. If you search the formula of the bond on Google, you will see that there is a big difference, which is the formula not divided by 2, because that formula is for 1 year, and this formula I show you all is the formula of bond for semi-annual. So this is the formula where beta naught equal to the bond value, C equal to the annual coupon payment, F equal to the face value of the bond, R equal to the required return on the bond, and T equal to the number of years remaining until maturity. So let's look at the example question where we need to find the price of a semi-annual coupon bond with a face value of $1,000, a 10% coupon rate, and 15 years remaining until maturity, given that the required return is 12%. If you notice, that the question mentioned for semi-annual bonds, so we need to use the above formula to solve the question. So the solution is like this, where C equal to coupon payment, so we need to calculate by 10% multiplied with the face value, which is 1000. Then we get 100 for C. R equal to required return rate, also mentioned 12%. T is number of years until maturity is 15, and lastly F is face value equal to 1000. Then let's see the difference between par bonds, premium bonds, and discount bonds. To differentiate each type of this bond is between the bonds price and face value, which is called par bonds when the bond price is equal to face value, premium bonds when the bond price is greater than face value, and discount bonds when the bond price less than face value. To differentiate between coupon rate and required return, par bonds occur when the coupon rate equals the required return on the bond. Premium bond occurs when the coupon rate is greater than the required return on the bond, and discount bond occurs when the coupon rate is less than the required return on the bond. So let's see what value is the bond at maturity. A coupon bond's value beta naught is equal to the present value of a stream of coupon interest payment plus the present value of the bond's face value repayment at maturity. You can choose the formula on above or below to be used, where beta naught equal to the market value of bond, I equal to coupon payment per period in ringgit Malaysia, M equal to par or maturity value of bond, usually at 1000 ringgit Malaysia, N equal to maturity or number years until the bond retired, K equal to required rate of return on the bond. The difference between N and T is number years until bond retired, and T equal to number years until maturity. We can say that a bond is something like we borrow money from someone, but you will lose a bit because of the interest coupon payment that you need to pay for the number of years issued. For example, a 3-year bond at a 10% coupon rate issue at par involve the following cash flow for the issuer at the investor and the investor. On the year the issuer got the par value or bond of 100,000, not included in the third year mentioned. Then the next year the issuer will pay 10% of the principal for 3 years, and the last year the issuer need to pay the amount of principal, which is 1000 plus 100. So the total pay is 1300, but the total borrow is 1000, means that the issuer lost 300. For the investor will pay 1000 to the issuer, then the investor will get the interest payment for 3 years, and the last year the investor got 1000 plus 100. So the total received is 1300, which is the benefit of 300. Let's continue the example by assume that you purchase a bond with 10 years remaining life with 40% coupon. The interest is paid semi-annually, and assume that the par value is 1000 ringgit Malaysia. If the required rate of return on bonds of this risk and maturity is 14%, what will the bond sell for? Since this payment is semi-annually, so we use the formula PVIFA KN. K, the required rate return, will be divided by 2 because we want to pay semi-annually, so the new value is 7%, and N is number year until retired is 20 because the question stated that 10 years and we paid 2 times a year, so 10 years multiplied with 2 we got 20. Then I is coupon payment per period by multiply 14% with 1000, we got 140. But this is for a year. We want for 6 months, so divide by 2 we got 70. So to calculate, just use the table PVIFA at page 215 in manual. And then we got the last value is 1000, so we set at par value. Why I said par value? Because remember what I presented before, the difference between par bonds, premium bonds, and discount bond. If we got bond price equal to face value, then it's par value. Now assume that 1 year has passed and the bond is now a 9-year bond. What would be the bond's value if the required rate of return were 8%, 14% and 20% respectively? So new N equal to 18 because 9 multiplied with 2 and new K equal to 4, 7 and 10% respectively. Just do the same as before and we got at K equal to 4%, bond price equal to 1,379.75 cents means greater than face value, so sells at premium. Then K equal to 77, same as before, sells at par value. Lastly, K equal to 10, bond price equal to 754, so less than face value, means that sell at discount. Because the ringgit amount of the coupons and maturity value remain constant, regardless of the change in required rate of return, the price of a bond rise and falls as interest rate change. When a bond is first issued, the corporation selling the bonds usually adjusts the coupon rate to be equal to the prevailing required rate, ensuring that the new issue of bonds sell for par value. The required of return on the bond will change as time passes and interest rate change. The coupon rate of the bond cannot change. However, because they are sold on the secondary market, the selling price and thus the yield to maturity can be adjusted to reflect changes in interest rates. In the preceding example, when the interest rate was 8%, the bond sold for 380 ringgit, more than its par value. This occurred because the bond offers a 14% coupon rate while the required return is only 8%. As a result, many investors will rush to buy this bond, driving up its price. If the bond is held to maturity at price of about 1,380 ringgit, the purchase earns exactly 10%, 8% and the price tends to stabilize. Bonds have several important points to remember. The first one is a bond will sell at par when the going rate of interest or yield to maturity YTM equals to the coupon rate. Second, when the YTM exceeds the coupon rate, a bond will sell for less than its par value. Third, when the YTM is less than the coupon rate, a bond will sell for more than its face value. Fourth, an increase in interest rate causes bond price to fall, while a decrease in rate causes bond price to rise. 5. As a bond's maturity date approach, its market value will approach its par value. Thank you.
For the next part is about the yield to maturity. So what is yield to maturity YTM? The yield to maturity YTM is the percentage rate of return for a bond, assuming that the investor holds the asset until its maturity date. It is the sum of all of its main coupon payment. A bond yield to maturity rises or falls depending on its market value and how many payments remains to be made. So this example of yield to maturity using a bond valuation formula. So it is given 9-year, 14% coupon rates with semi-annual coupon payment and a 1,000 par value bond at a price of 950. So what rate of interest will we earn if we bought this bond and held to maturity? So we solve using a bond valuation formula and find the rate of interest that makes the value of bond equal to 950 selling price. So this is formula of bond valuation formula. So when coupon rate at 14%, so BO equals to 1,000. So this the 70 is a coupon payment. So this is present value of annuity, and this is a par value. So the BO will equal to 1,000. So when BO 950 is less than 1,000 par value. This means K should be higher than 14%. When 16%, the VO equals to 906.23. So we have the three value of VO. So the actual rate of return is between 14 and 16. So by using the interpolation, KD minus 14 divided by 16 minus 14 equals to change of 950 and 1000 and divide by 906.23 and 1000, which is 93.77. So we'll got KD equals to 15.7%. Since the bond is selling for less than its par value, the required rate of return or yield to maturity must be greater than the coupon rate of 14%. If the selling price more than the par value, the rate of return should be lower than 40%. So we also can use the yield to maturity formula, which is YTM equals to I plus M minus BO over N divided by M plus BO divided by 2. So I is coupon payment, M is face value of security, BO is a price of security, and N is years it takes to reach the maturity. So from the formula, we substitute the value, so and then we get 7.46%. To get for the yearly, we will multiply by 2 and we'll get 14.92%. The equation is an approximation and it will not produce exact answer. The approximation gets worse as the interest rate gets higher. So all cost of bond calculated must be converted to after tax basis. This is because interest are paid before the tax and do not have the same basis as the dividend that is paid after tax. Assuming tax is 40%, so KD there will got before 14.92 times 1 minus 0.4 and we'll get 8.95%. This is after tax cost. The after tax cost is 8.95% under YTM method, and this cost will use in the comparison since it is on the same after tax basis as the cost of dividend. So next we'll go to the interest rate risk on bonds. Since the bond offer a fixed stream of payments, the bond price or value will change within the interest rate. This means that the holders of bond will find the value of their bonds 187 changing as the interest rate. The risk of changing bonds due to change in the interest rate called interest rate risk. The change in value is shown in the following table for 10% bonds with par value of 1,000 with different maturity. So this table of price volatility of bonds. So from the table, two features of bond affect the price of volatility in response to change in market interest rates. A bond with a lower coupon rate will be more volatile than the bond with the higher coupon rate. Also, the longer term bonds are more volatile than the bonds with a shorter time to maturity. Volatility in this case is the amount of bonds price changes in the response to a specific change in the interest rate. The graph that we can see, we can explain about the risk and gains. The risk of bonds where volatility depends on which way interest rates are moving. If the rates are falling, it is better to own long-term bonds because higher volatility means higher bonds price. If rates are increasing, you want to own lower volatility short-term bonds to minimize the price decline in your bonds holdings. Bond price volatility does not happen on its own, but it always a result of interest rate change in the bonds markets. So we can see that the longer the maturity of bond, the more volatility it is its price with respect to changes in the interest rate. This volatility exists because the investor is looking himself into a fixed stream of payments for a longer period of time, while interest rate varies in the market. So that's all for me. Thank you.